that all the way out. All right, so let's do it. Let's cross our fingers. All right, so A real quick. Let me do this real quick so I can get the answer written down. We go d by dx minus sin y d by dx. Is that showing up there? Yeah. Okay. All right, that's as far as we got yesterday. Correct? Okay. Similar questions then kind of follow up to that previous AP question from the day before, where you're going to write an equation for each vertical line tangent to the curve. So for the first time now, we're writing the equation of the vertical tangent line. But we talked yesterday about how when you see these words, vertical tangent together, that then takes us back to the previous chapter that we just tested on. The idea of a vertical tangent makes our derivative undefined. So that takes us to this idea. Is undefined. That then kind of jumps us to the next idea that if we look at this equation here, with this being a rational expression where we have a variable in our denominator, what would make our derivative undefined in this case is the same thing that happened on the previous page, is that our denominator, so let's do some part B, the denominator of 1 minus sine of y would have to be equal to a 0. So what would make our denominator equal a 0? So that's what we do. We take that denominator, set it equal to 0. Okay? So little trig equation. The first one that we've solved, you certainly probably solved some much more complicated trig equations last year. This is kind of the introductory trig equation. And really what we do to solve this one, trig equations in general, a lot of times we don't want those set equal to 0. So I'm going to add the sign over. And then what we're just thinking about is on our circle here, the sine of what angle has a value of 1. So when we go around our unit circle here, we want to know which one of those angles has a y coordinate, since it's the sine value of a 1. All right. So hopefully we can think that through a little bit. We know our circle reasonably well. This point up here is the point 0, 1. We would then hopefully know that that is the angle pi over 2. So then that's our y coordinate. All right. So now, this is a real true algebra test here. We'll see who's really good with their algebra now, because this is the next step. All this gives you is the y coordinate. What we are ultimately doing is writing the equation of our vertical tangent line. So do that and see what we think we're going to get. And I'd be impressed if we get this. It's so easy that it's hard. Now I have people in class to call in too. They can't. Although I look at the back of everyone's head in here. Emma's got the bright red hair. I like that. It's good stuff. Learn that Jade's a lefty. Who knew? I didn't know Nick was on the cross country team. Learn all kinds of stuff about people now that they're in the building. All right, let's see what we came up with. It's really just straight, 7th, 8th grade algebra, but it's something that people in general have a hard time with when we're dealing with this in algebra, where if we're going to write the equation of a line, specifically a vertical line, normally we say we always need a point and a slope. That's not necessarily wrong. We still definitely need that. We know now the y coordinate of our point. And that's what we're saying right here, is that our y coordinate is that pi over 2. We would still need our x coordinate, so we'd have to go to the original equation. Let me see what that was. So y plus cosine y equals an x plus a 1. And we're going to let our y be pi over 2. So I would get pi over 2 cosine pi over 2 equals the x plus a 1. We can now solve for x. The cosine of pi over 2, so that's the same point that we're talking about right up here. That's the x coordinate. We can see there the x coordinate is a 0. So this will just drop out. And we get our x coordinate to be the pi over 2 decreased by 1. Which means I need a little more room in my point to write that in. So up here we have pi over 2 minus a 1. We then need our slope. Write down what our slope is. All right, and again, so easy that it's confusing. Our slope is given to us, right? We don't have to plug that in and evaluate our slope. We were told that we have a vertical tangent line, so our slope would be said to be undefined. That's what we always said about vertical lines when you would have talked about slope. Maybe you said no slope, undefined, or no slope, kind of interchangeable. So what makes this hard is we can't write an equation like this and do y minus pi over 2 equals and then put the word undefined here. It doesn't work like that. We can't use a word when we're trying to write an equation of a line. So this is the one instance where we can't just use point slope form. Did anybody come up with this? Anybody feeling smart? Want to share out? Feeling clever? Nick, got it?
I just said x is equal to pi over 2.
All right, Nick says this is our answer, pi over 2 minus a1. I like that. All right, it's a smiley face. Remember what a vertical equation looks like? The equation of a vertical line is always x equals some number. So once you have that number, when we do that right up here and get this x coordinate, this is the equation. That's not a good sound. What was that? I feel like we're on borrowed time right now. Plug along. That ends up being our equation. All right, pi over 2 minus a1, x equals pi over 2 minus 1. All right? Good. Nice having people in class. All right, letter C. C is what we did yesterday real quick. It was the somewhat new thing. Just do the second derivative. And all the second derivative was taking the first derivative, v1 over 1 minus sine of y. Fix this. And then just doing the derivative of that. So quotient rules, probably how I would approach this. Denominator. Derivative of the numerator is going to be a 0. Then we would subtract, leave the numerator. The derivative of our denominator, the 1 would have a derivative of 0. The derivative of a negative sign should be a negative cosine. You would leave its inside alone. But then we'd still have to do the derivative of the inside, and that's where we come across the y. And the derivative of y, even in the second derivative, we'd have to put down dy dx. All that gets divided by your denominator squared. Don't get too worried about simplifying this. I see a lot of people just make mistakes simplifying. This obviously is going to cancel, so that we would want to just show because multiplying by 0 will go away. So the last thing you would just need to do, we'll go ahead and say the negative 1 and the negative cosine is a positive cosine. And then our denominator is still that denominator squared. The last thing I would expect you to do is where we have this dy dx term, we're going to replace that with what we knew dy dx was equivalent to from the previous work. So instead of the generic dy dx, we plug in the 1 over 1 minus sine of y. Okay. All right, good with all that? All right then. One more, go to the next page. You're going to see some very, very similar questions. This kind of, we try to do as many AP questions and we can mix them in as we can throughout the year. They tend to reuse similar types of questions. They switch things up a little bit. but really, really similar questions here. All right, so go to number 3. Number 3 gives you the curve. Letter A, it says write an expression for the slope of the curve at any point. So this is something we've talked about quite a bit now. When we start talking the slope of the curve at any point, that's your derivative. That's what the derivative finds us for x and y. So that we should be able to do. So go through number 3. Last day of this, we would normally have a quiz the following day. Hopefully we can get through this one pretty well. All right, and then the really the only thing to be careful of is that second term where you have the product rule between the x and the y. Of the 4 terms, 3 of them should be very easy. It's just that second one, making sure we handle this correctly. So it's just this product rule. So product rule is you take the derivative of the first term. So the derivative of x would be a 1, leave your y. Then in the product rule, we're supposed to add. So we're going to do a plus, leave the x alone, and then take the derivative of the second term. And then that's our dy dx. If you got that, then it's just some simple algebra there. We're trying to isolate the dy dx's. So we're going to take the 2x and the y, we're going to subtract it over. I'm also going to factor out the dy dx from the 2 terms that remain. So we get x plus 2y times dy dx. Divide that. And hopefully, after spending a few days on this now, our 3rd day, we can get this answer. All right. All right, letter B. Another little twist. So they're not all the exact same thing, but they just do a little tweak. Read letter B. See if we can kind of get that started. How would we handle that? What's it ultimately asking for? And then we'll come together here in a minute. All right, let's see if we've got a thought process here. I'm gonna kind of draw out what the question is asking, and that kind of guide what we're looking for. So you were given this curve x squared plus xy plus y squared equals a 27. So that curve, it's some sort of elliptical shape. It actually might be kind of this little figure 8 looking thing. So let me kind of sketch in something that maybe looks like this. Actually, I don't like that. Let me get rid of that. Let me do something that looks like this. What the question is asking, if you go to your x-intercepts, so here and then here, for me, the one that I drew in, we'd have 2 lines tangent. So at this point, I'd have a line tangent that looks like this, and I'd have a line tangent that's almost vertical, possibly. We'll make it somewhat of a positive slope and not say it's vertical. So what it's asking then for my graph, so don't think this is what it actually looks like. But at the x-intercepts, are my two tangent lines here, then in red, are they parallel? No. And then by looking at mine, it's very clear they're not, because we can just look at the graph and determine that. If we don't have the graph, what we would need to know is what are their slopes? Because we know if their slopes are the same, we could conclude that they are in fact parallel. So what the question is really asking is, at the x-intercepts, what slopes do we have? If they end up being the same slope, then yes, they're parallel. If they're not the same slope, then no, they're not parallel. So it's a slope question. Slope pertaining to our derivative. So we already know our derivative, right? I don't want that. So dy dx, no idea why this is red, equals a negative 2x minus a y over x plus 2y. The problem we have right now, if I want to figure out slopes, we don't have any points to plug in. Like, what point are we plugging in? Well, the points they want you to plug in are your x-intercepts. So again, old algebra stuff. If I want the x-intercepts, hopefully in our head we're thinking, okay, I know something is always true when I cross the x-axis. And that's something that is always true when you cross the x-axis is your y-coordinate is a 0. That's how we're going to get this point. So what we now need to do, create some separation here. We need to take that original equation, the x plus 2y, x squared, here. So here's our original equation. We want to let our y's be a 0. And then very quickly, we get two x-intercepts of a positive and a negative root 27. Right. Now all we have to figure out what are the slopes at these points, because it's really two different points. It's root 27 comma 0, negative root 27 comma 0. You're going to plug that into the slope. If they give us the same exact slope, then yes, they're parallel. If they're not the same slope, then you're going to say no, they are not parallel. All right, so I'm going to fill in this one up here, root 27. So at the positive root 27, I would get what? Negative 2 root 27 minus 0 over root 27 plus 0. Make this a little bigger. So for this one, we get a slope of negative 2. That's our first slope at the first x-intercepts. If we now find the slope at the second one, so now I'm going to evaluate this at a negative root 27 comma 0. So we do a negative 2 times a negative root 27 minus the y-coordinate of 0 over x, which is a negative root 27 plus a 0. Got a lot of negatives going on there, but hopefully simplify it, keep all that straight. Does that also give us a slope of a negative 2? Yeah. All right, so then these are our x-intercepts. These are the slopes at the x-intercepts. Because those slopes are the same, then we would say, yep, those lines tangent at the x-intercepts are parallel. They don't ask us to explain it, so you don't really want to start throwing too many words down. They just say show the work that leads to your conclusion. All right, so we same slopes, write our conclusion, and then we move on to the next part. All right. Okay, last one. Go ahead and try letter C. I'm going to give you a few minutes. I can actually act like a normal school year teacher and walk around the room, see how people are getting this. But try letter C. It was one of the new things. It is the most common follow-up question with this type of a topic. We've done it a few times now. See if we can get all the way through this. Okay? See where we end up. It's an easier version of the first one we did yesterday. Much nicer numbers to work with. Although I won't get too close. Okay, if you're stuck, it goes back, one, understand you're finding a point right now. So we need both an x coordinate and we need a y coordinate. The points we are looking for is the point on the curve or points on the curve where our tangent lines are vertical. So now, third question, third time that this has been asked. We go back to, same thing, equation for our vertical tangent line. Think about how we had to start that. When we went back to that first question yesterday, first time we saw it, tangent line is vertical. The big difference right now is yesterday we wanted an x coordinate. So when we did that problem, if I wanted an x coordinate like we did yesterday, then we really don't want y's in this equation. We need to get rid of the y's. So when we did that problem, we solved for y so that we could use y to get substituted in. Because we only wanted x yesterday. So that's why I think that was x squared over a 2. We went back to that, and then we took this and we plugged it in to those two spots to get rid of all of our y's. But we did that because we only wanted x's. This one, it doesn't matter. We want both x and y. So which one you solve for now shouldn't matter, but hopefully, crossing my fingers, and if not, you have time to get there. When we see this phrase, your tangent line is vertical, we can immediately make two quick jumps. That our derivative is undefined. That's how we've referenced the tangent line being vertical. So that hopefully pops into our head very quickly. And then with regards to these questions, so if I had room, I'd draw an arrow there. That then tells us in these problems that means our denominator in the derivative is equal to a 0. That's what would make our derivative undefined for these types of problems. So if we go to this problem, what we're really looking to do is take our denominator and set that guy equal to 0. That's when we have a derivative that's going to be undefined. So now yesterday, and that's why I kind of referenced before. Yesterday we were looking for x's only. That's why we solved for y yesterday. Now it doesn't matter. You need x and you need y. It doesn't matter which one you solve for. If it were me, I would avoid fractions, so I would just solve this one for x. If you solve for y, totally fine. You'll get the same exact answer. At least we do everything algebraically correct. We'll get the same exact answer. but I would solve for the x, and then I just don't have to deal with the fraction. So now what I'm going to do, I'm going to go back up into this original equation here, since I want points on the curve. Wherever I see an x, I'm going to get rid of it, and I'm going to replace it with what we just said x is equivalent to in terms of y. So now I'm going to do a negative 2y quantity squared. And then I'm going to do a negative 2y times a y. Now we have an equation that will give us the y coordinate of our point. All right, so we'll do 4y squared minus 2y squared plus a y squared. This equation I was saying earlier, much easier than the wild one from yesterday. Those all end up being like terms. They're all y squareds. We're going to add them all up, 3y squareds. Divide by 3, and we should get y to equal a plus or minus 3. I forgot how it was worded, but it alluded to the fact that there's definitely a possibility of more than one answer, and there is. So we have 2 points right now. One of them with a y coordinate of a 3, the other with a y coordinate of a negative 3. That's what this is telling us. All we need now is the x coordinates. So think about how could we find the x coordinates. If we know y, how can we find x? There's an easy way, and there's a, I wouldn't necessarily say super hard way, but definitely a longer way. What will always work, if you know y and you want to find x, you could just take these y values. You could plug them into the original equation. That always works. That's the little bit longer way, not that it's terribly difficult. However, there is a much quicker and simpler way, correct? Hopefully we can kind of see what that quicker, simpler way is. And that's using this guy right here, that we know x is always equal to a negative 2y. So if we know y is 3, then x would be a negative 2 times 3. So this has an x coordinate of negative 6. And then last one, throw in a negative 3 here. So a negative 2 multiplied by the negative 3 is a positive 6. And then that's the x coordinate in that point. All right. Be able to do one of those. Very, very, very strong chance you'll get at least one of those where you have, where do we have a vertical tangent? Your denominator is 0. We got to be able to work our way through and solve for that. All right. With that, let me just show you this, and then I honestly don't remember what's on that review that I have. If there's anything we need to talk about, we can. Not. Oh, do I not have Canvas up? Shoot. Yeah, so let me pause this.